my screen as well. So let me know if you can see my shared screen. You kind of let me know. Okay, could you let me know if you can see my screen, guys? Oh, good, thank you. All right. So today's class would be focusing on chapter 3, like I said, chapter 3 of the course, and chapter 3, we're going to be looking at repetition statements. Which is the iterative structure of programming using the C language. Now, when we say repetition, what do we mean, or what should you understand by the word repetition? I'm going to explain that in a while to us, and for us to understand what we're doing. So when you repeat, just like the word means to repeat, the word states to repeat means to do something over and over. So when you're doing some programming, there are certain blocks of statements or blocks of program that you would love, to repeat, that you would love to make them continue in a loop. Okay, we'll call it looping. So you want to perform some looping actions or statements. So we'll need to repeat some events, maybe one or more statements or block of statements. But repetition depends on two things. Okay, so generally that depends on two things. One of the things that you need to consider when you're going to perform this type of function or this is required for the repetition or the iteration to stop. Okay, so you set a stop condition after you specify the number of iterations. Okay, maybe for example, the process is going to repeat itself 5 times, and then there has to be a stop condition. Okay, so those are two things that you need to be mindful of. You need to know when you need to know the number of repetitions that you want to do, and also you need to know at what point should that iteration stop. Okay, so two things there. So, but in C language, we implement the iterative structure or this repetition with 3 basic statements. Okay, so in C programming, like I said, in C programming, or in C language, I'll say in C language, we implement iterative structures using three basic statements. One, we have the for loops, 3 kinds of loops. And when do we use the for loops? We use the for loops to basically set a condition that as long as this condition is true, you will set a boundary or a bandwidth. You use this when the number of iterations are known. So let's say for 5 times, for 20 times, for 10 times. So you use this generally when the number of iterations are known. Okay. When you know the number of iterations, like let's say you want the process to repeat for 5 times, then you can use the for loop statement. Okay. Then we also have other kind of statements that you can use. The second is while loops. Okay, so when do we use while loop? This while loop depends on a condition. We use it when the iteration depends on something, depends on a condition. So this is used when the iteration depends on the occurrence of an event or on a condition. Okay, so you can put it that way. Depends on that condition there. And again, we also have the do while loops. So this also depends on when the iteration, depends on a condition. Okay, when the iteration depends on a particular condition, when that condition is met, when you specify that condition, and then the looping can stop, or the loop process might be suspended. You might suspend the looping at that point. So what next do we have to take note of here? Just a moment, guys. So, okay. So I'll just go through this again with you. From the beginning of the chapter, we're considering repetition or repetition statements. There are certain times you want to perform a task, and you want that task to be repeated over certain time, over a number of times, I will say. That you can also do with C programming. And there are conditions that we can set for it to keep repeating itself, like we have said. So you can set the number, it depends on two things rather: the number of iterations that you need to carry out, and then what is the condition that is required for that iteration to stop. So we have discussed three types of repetitive or iterative structures. This is structure that we use in when we are carrying out C programming. And one of that is called the for loop. So when you use the for loop, you are specifying a condition that when that number of iteration is reached, then the looping can stop generally. Okay, so where we can stop the looping, we know the number of iterations that are supposed to be carried out. And then we can also use the while loops, and we can also use the do while loop. And in this case, it depends on the condition. When that condition is reached, the condition that we state for our program, when that condition is reached, then it can stop. Right. So let's look at the while loop. Let's take a look at the for loop. I'm sorry, beg your pardon. Let's look at the for loop. For loop. Okay, for loop. So the for loop basically has three formats. The format can be grouped into three. So I'll state the format for you. The format is this way: you put for, then I assume that A is a variable that's been defined. A equal to 0. There's a semicolon there. Then A is less than 10. This is a semicolon, and A plus plus. So I'm going to explain to us what this means in when you're using a for loop. So for a for loop, you want to repeat some processes. You want to repeat some actions. But in repeating these actions, first, the first step is that you need to set an initial value. That's step one. You need to set an initial counter or initial value. So your initial counter tells the program where to begin from. what number do you want to start from? Okay, are you starting from number 0? Like in this case, we say A is equal to 1. A is our counter variable. So A starts with 1, or A starts with 0, or if I put 1, that tells the program that it starts from 1. Okay, but if I put 0, it tells the program that it starts from 0. That's positive numbers now. Then the next thing you need to specify, or the step number 2, is to check the stop condition. Okay, check the stop condition. All right, so if the condition is true, execute the repeating statement. Okay, but if this condition is false, the loop it will exit the loop. So what is the stop condition we have here? The next thing, that's the stop condition. The stop condition tells us that A, this variable, must be less than 10. So if at any point we enter the value 10, the loop will stop. So the loop will only continue if the value of A is between 0 and 10. I'll write it again. So this loop will only continue if the values of A is between 0 and what? And 10. Is between 0 and 10. So at any point you put a value that is greater than 10, the loop stops. Okay, it stops automatically. That's your stop condition you specify there. Then the next step is step number 3 that you have to do at the end of the repeating statement. At the end of the repeating statement, you update the loop counter, and then you go back to step 2. So at the end of the statement that is supposed to repeat itself, you update the loop counter, that is A. You update it with a count. So in this example, we are increasing it by 1. So if the value that was entered here, for example, let me write this down first, sorry. At the end of repeating statement, update the loop counter and go to step 2. It will go back to step 2 to check, is the value less than 10? Is the value more than 10? Then if the value is less, it repeats itself again. Okay, after we give an example, I'm sure that you guys will understand this much better. So in this case, if the start value for A, let's say, is equal to, okay, the start value is 0. So when the moment we run this loop, what will happen here is that it will increment, A will increment. The first value of A is 0. The second value of A would be 1, because it keeps increasing by 1 each. And when it increases by 1, it goes back and check the condition, the stop condition. Is it true or false? If it's true, in this case, the stop condition is true. Is true, yeah, that A is less than 10. Then it goes and repeat again. It checks again. After this, it performs this operation. It increases itself, like increases to 2 here. It checks, is that true? If it is true, then it's increased again. It does the function again, and then it's increased by 3. It keeps doing this until we get a value that satisfies the stop condition. 7, A equal to 8, A equal to 9, then A equal to 10. At this point, A equal to 10 is going to be false, okay? To be false. But here is true. Okay, so we have true, 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 true for all of it before 10, because the stop condition has been stated that the value of A shouldn't be greater than 9, should always be less than 10. So when you impute 10, when it repeats itself for the 10th time, number of count that A has counted, starting with 0. So we have performed this statement 10 times, because if you count from 0 up to 9, that is 10 times in total. Okay, so if in this situation, what we want to see here is, for example, print f. If you want to print f, this is ENG 102 class. Maybe that's what you want to see, okay, in your program. This is what you want to see repeated. So at this point, this is how it's going to, the output is going to look like this. Your output is going to look like this. You're going to have this type of output. For each of the repetition that your condition is true, you're going to have the similar output. But here, there won't be any output. Why? Because the condition is false. I hope you understand how to use the for loop. So we're going to go into some examples and see how in practical terms we can apply the for loops, and how it can be used for previous examples that we had considered in our previous classes. But I'd like to know if there's any question at this time. If you have a question, can you ask, and then we would proceed. So for this to happen like this, we need to put this on a new line. So that's going to be n there. So each repetition has to happen on the separate line, So that's what we do there. So to complete this program, we should, of course, use this. And then we have so we define A as an integer. So we specify our for loop there. And then when we do all of this, then we say return 0. Then we close it. So this would be our output. Output is just going to be this. Okay. So that's going to be your output there. So, but that's your program that you should write in a nutshell. Okay, did I answer your, someone is asking, what's his name? You're asking a question there. Is your question answered? Jeremiah. Okay, you're asking why we didn't put the new line for each paragraph. Okay, I already corrected that. Thank you. So that's how your program is going to look like. So you first have to define A as integer, your count, that's your count variable there. So you set the start condition like we've said before. It has to have the start condition, the stop condition. So the starting point, I'm sorry, the initialization point. And then we have the stop condition, and then this is how you increment it. There might be other function you want to perform here, as we're going to be looking at other examples shortly. Okay. All right, so we will proceed with more examples. Okay, someone is asking a question. Can we display something once the conditions is false? That's up to you. Yes, you should be able to do that at the loan. You can display anything if the condition, you can make that statement, else you can write that whatever you want to display there. that can be stated. So when we get there, hopefully you should understand it better. Yeah. All right. So let's move on with more examples if there are no more questions. So on the normal programming, let me undo this stuff I did now. Yeah, I want to show us something here. Um, okay, if you look at this example here, we can actually write it in another way. Okay, the way we used to do that before. So if we're going to write this another way without the for loop, it's going to look like this. You take out the for loop, and then we are printing this. We're all not going to have anything here. So we're just going to print F. This is blah, blah, blah. And then we keep repeating this for the number of times that we want it to be repeated. Okay, so that's what we're going to be doing. For up to 10 times, we're going to repeat this. So if you compare this solution with the previous solution, you know which is easier. So both is going to give you the same result. That's the point I'm trying to make here. These and the first that we did, but I mean, in the other case, it's easier for you to manipulate things. It's easier for you to troubleshoot, and I mean, it gives you more flexibility, I would say, to add other features that you want to do. So that should be 10 there. So this is how you can have it without, if you're going to do this without using the repetitive statement or the for loop. If you're not going to use the for loop, this is how your program is going to appear. So let's move on with other examples now. So still on the for loop. Now, if we consider this example, include Mosa, you're saying it should be 9 times, not 10 times. The last one is false. Yes, it shouldn't be 9 times. I'm going to show to you. I explained that to you already. Okay, let me explain it to you a little bit more with this example. So please listen up as I go back to that page. Okay, I lost that page. I need to I'll create that page here again for you. Okay, so I'm going to write the same thing here for you. Int a. So we put our for loop here. A is equal to 0. A is less than 10. And A plus plus. Increment. So what do we want to print? We print F printf, this is ENG102 class. Then you return 0. Okay, so when we follow this example, was there another question? Okay, so Mart, I want you to listen up. When you follow this example, is the starting point, like I said to you, is 0. So if you start at 0, the last number here, the maximum number is going to be 9 because A should be less than 10. So if you count from 0 to 9, you should have 10 iterations. What do I mean? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you count all of it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 iterations, not 9 iterations. Okay. Did that answer your question, Moad? Good. Thank you for asking that question. So then also to further follow up your question and make it clearer to you, if you put 1 here, if your start point is 1, the results that we're going to have here is going to be 9 because we are starting with 1. So if we start with 1 iteration, the initialization number is 1. So it's going to be 1 time 1. The second time we're increasing it. The fourth time, 5, 6, 7, 8, 9, 9. So that's exactly 9. Okay. So, but what if we put A to be less than or equal to 10? So at that, then we can also have 10 here again. So we could use this or the previous example. Is that clear to us? Is that easy to understand, everyone? Okay, good. Thank you, guys. So we'll move on. Well, see if we have something we can do here, something interesting. Yeah. So let's do this example together. Let's do this example together. Example. Write a C program which will take 5 integer numbers. We did this example before previously, if you remember, but we want to do it using the iterative structure now from the keyboard and display how many of them are odd numbers. Okay, so I'm going to do both solutions for us. We're going to do both solutions. The initial solution we did, and also we're also going to try to do it with the iterative structure, solution and see what we can get from there. So that's our example there. And so if we solve this with the iterative, with the normal solution, which we did in the class previously, so we should have it this way. So what we're trying to do in this example, what is the question? What does the question expect us to do? The question expects us to, let's get some space here, to write a C program, which will take 5 integer numbers from your keyboard, and it's going to display how many of them are odd numbers. Okay, if you remember, we did this perfectly in the class. So we're going to take integer numbers as X, and then we need a count, an odd number count, because we need to count how many odd numbers. Then we initialize it to be 0, the starting point. We start with 0. Okay. Then after initializing it, what should we have? We have the printf statement that says enter X. Okay. Then at this point, we also use the scanf statement to receive the values of X. X is in there. Okay. Then here we used, in that example, we used the if condition. We use if X is, if you divide X by 2 and it is odd, okay, then you should increase your odd count, because that's what we're trying to do, your odd count by 1. Increase it by 1, that's plus plus. Okay, so this is what we're trying to achieve here. So the question said we should take in 5 integer numbers from the keyboard, displayed how many of them are odd numbers. So you take it first, you count it, you increase your odd count if it's divisible, if you divide it by 2 and the value is, if it is odd, and in any case, that's it. So if that's an odd number, so you can just put a comment here and say, if it is an odd number, okay, if it's an odd number. So that's what you're trying to do there. So you increase your count by 2. So you have to continue this process for 5 times. You need to tell them to enter it for 5 different times. So what that means is that we're going to repeat this process again 5 good times. So this is what it means. And this is 2 times we repeated it here. And to create another. So we repeat it here again. That's the 3rd time we're repeating it. Repeat it for the 4th time and then the 5th time. And after the 5th time, we also write a printf statement on a new line, printf on a new line. Then you put there R. Then we want to count how many odd numbers. Odd numbers. That is odd underscore count. And you return your statement. You end your statement there. Okay, so in the normal procedure that we did previously in class, this was the way we did it. We have some questions. Maud, you're asking me to explain X. You're asking me to explain this. I thought we explained this long time in the class. He's asking me to explain what this means. This means X, the value of X, if you divide it by 2. If you divide the value of X by 2 and the result is 1, if the result is odd, if the result is 1, okay, then it's an odd number. But if the result is not 1, then it's not an odd number, okay? If the divisibility of this, not the result rather, if the divisibility of this will give you an odd number. I don't know if that makes sense. We explained it many classes ago. I mean, before the sit at home policy began, I remember I did this explanation for you, okay? All right. Oh, good. So he's fine with that, okay. So this is the normal solution that we should have done. So let's use the iterative solution. The iterative solution now. How would it look like when we use the iterative solution? We, of course, certainly we're going to use the include input, standard input and output headers there. So here we have integer X as the one that we're going to use to take the numbers. So X is the variable that will collect the numbers from the user. And then we have to define an odd count because they ask us to count how many odd numbers. Okay, so we're going to define the odd count and again set an initial value for it to be 0. And afterwards, we are also going to define one more variable. And that variable is responsible for counting the number of the loop count or the iteration count. Okay, so the iteration count here, instead of repeating it 5 times, we're going to put our iteration count as n. Okay, so the n is going to replace, if I go back here, this number of iterations that we did in this previous example. Okay, in these previous examples, we had a couple of repetitions here. So instead of putting in these repetitions, we're just going to use n there. And then when we had specified n, we'll go ahead and put our for loop for n. So n becomes the counter equal to 0. We're starting from 0 because they told us 5 times the question. Let's go back to the question again and try to understand the question. So if you look in the question, I don't know what's happening here. I think I repeated something here. Let's delete this. Okay, good. So here is a question for us to write a C program, which, so we're writing a C program, which will take 5 integer numbers. So the 5 integer numbers means that we should specify a loop counter because it's going to repeat itself from the keyboard and display how many of them are odd numbers. So we go back to where we stopped, the iterative solution there. And then we try to continue with that. So we set n to start from 0, and then n should be less than 5. So between 0 and 5, sorry, less than 5. Okay, because between 0 and 5, which is 0, 1, 2, 3, 4, there are 5 counts. There are 5 repetitions there, 5 loops. So you're going to increase n each time by 1. So it's as simple as that. So what's going to be the program that we want to repeat there in that report? Sorry. So here we have printf. You tell them to enter X. So here you don't have to tell them to enter first value or anything. You don't need to repeat it like we did in the other time. So once they enter the first one and you collect it with the scanf statement, you can just simply proceed. So now here is where we state the condition, okay? The odd number collection. So if X is odd, we write it this way. If X is odd, then the odd counter which we defined in the first place should be increased by 1. Okay, that's the odd count that we define here. We defined it here and we set it to be 0. So it begins to increase from 0. So we count 1. If the first number that's entered is odd, and 2, so 1 will be replaced by 0. Initially, there was no count. And then anytime you get an odd number, it is replaced here in the counter. If you get the first odd number, it's going to be 1 there. If you get another one, it's going to change from 1 to 2. And that's how it keeps increasing until you get to where you need to be. So we've done that there successfully. Then finally, we need to print the number of iteration, beg your pardon, the count there. Then you say that there are how many, it's counted there, odd numbers. So we pick it from odd count. So the odd count will give us how many odd numbers that we received. Yeah, so this is a simple solution that a solution to such an example that we had done previously using the iterative solution or the iterative structure. So I hope that this comes in handy to us. It's not difficult for us to understand. If there's any question, yeah, I can take the question before we make a break. Alexis, he said there is a mistake there for have odd and not add. I really don't understand your question, but let's go through it again, Alexis. So we said for n equal to 0, starting point, the initialization, 0. The stop condition is when n is less than 5. Increase it. And where's the mistake? Print f, enter this, scan f this. So this is the condition. If this is odd, this is an odd number, you increase the odd count. Okay, so where? Oh, thank you. I saw the mistake now. Okay, this is odd, not add. Okay, that's a typographical error. So it's odd count. Okay, so that's odd count there. Yeah, so if we don't have any other question, we can make a break now and then we'll be back by 10 minutes past 10. There's no more questions. We can see, we can come back, regroup again by 10 minutes past 10. So I'll see you 10 minutes past 10. Bye for now.